Imagine you are standing under a dark night sky, far away from the bright city lights. The stars twinkle above you, ancient and distant, like cold fires scattered across a black ocean. Most of those stars have been watched for centuries, and most of the objects that drift through our solar system, comets, asteroids, and even the faint planets at the edge, follow familiar, predictable paths. But every once in a very long while, astronomers spot something that doesn't belong, something that doesn't circle the sun the way our native comets and asteroids do, something that comes from far beyond. That was the case in the spring of 2024, when an automated survey telescope scanning the skies for dangerous near-Earth asteroids picked up a faint moving dot of light. At first glance, it looked like just another small, rocky traveler orbiting our sun. But as more observations came in, something remarkable was revealed. Its path was far too steep, far too fast, and far too hyperbolic to be from here. It wasn't bound to the sun. It was just passing through. That faint speck of light would soon earn the name 3I Atlas, the third interstellar object ever discovered in human history. The 3I means exactly that, the third interstellar confirmed by astronomers after Oumuamua in 2017 and Comet Borisov in 2019. And the Atlas comes from the telescope that spotted it, the Asteroid Terrestrial Impact Last Alert System, a survey project based in Hawaii. In other words, a telescope designed to protect Earth from potential asteroid impacts had accidentally caught sight of a messenger from another star system. The detection itself was subtle. To the untrained eye, the discovery image would look boring, just a star field dotted with pinpricks of light. But to astronomers, there was one tiny dot that betrayed its secret. It shifted position ever so slightly between frames. When computers compared the object's changing coordinates with known orbital models, they quickly realized something strange. The orbit was not elliptical like all planets, asteroids, and comets bound by the sun's gravity. Instead, it was hyperbolic, the shape you'd expect if something came in from infinity, swung past the sun, and then sped back out into deep space. Within hours, observatories around the world were alerted. Teams scrambled to track the faint speck before it faded beyond the reach of smaller telescopes. These early measurements were critical. With objects like this, every night counts. The longer you wait, the dimmer the visitor becomes, until eventually it vanishes into the background noise of the cosmos forever. To appreciate just how extraordinary this discovery was, it helps to remember the numbers. Our solar system is vast. It stretches billions of kilometers from the sun to the edge of the Oort cloud. And yet, in all of human history, we had only confirmed 2 interstellar visitors before this. That makes 3I Atlas not just another asteroid, but a rare cosmic guest. One of perhaps countless fragments wandering between the stars, but one of the very few to cross paths with Earth in a way we can actually study. For astronomers, finding such an object is like hearing a faint knock on the door of your house, only to realize the visitor came from the other side of the galaxy. It sparks questions immediately. Where did it come from? How long has it been traveling? What story of distant planets, collisions, or star systems does it carry with it? When 3I Atlas was confirmed, there was excitement, but also caution. After all, the first interstellar object we ever found, Oumuamua, had become a source of intense debate. Was it a comet? An asteroid? Something else entirely? Its strange, elongated shape and unusual acceleration puzzled astronomers, and some even speculated, though without evidence, about alien technology. Then came 2I Borisov, which looked more like a typical comet, venting gas and dust as it warmed near the sun. With 2 very different examples already known, the third discovery raised a big question. Would 3I Atlas resemble either of them or surprise us again? The first days after detection are the most crucial. That's when astronomers gather as much data as possible: brightness, trajectory, and even hints of its physical makeup. The early glimpse gives a foundation for everything that follows. With 3I Atlas, the excitement was not only about its path, but also about its speed. It was moving at tens of kilometers per second relative to the sun, too fast to be captured, too fast to belong to us. That speed alone was like a fingerprint of interstellar origin. Imagine tossing a stone across a pond. Most pebbles sink quickly, trapped by the water. But occasionally, one skips across, tracing a line that proves it didn't stay bound. That's what 3I Atlas looked like. A cosmic stone skipping across the solar system, untouched by gravity's net. When scientists speak of discoveries like this, they often focus on data and numbers, but there is also a human side to it. The idea that a fragment of another star system, perhaps from a planet that never formed, or from the violent breakup of a distant comet, is now flying past us, can stir deep feelings. For many people, it brings a sense of connection to the wider galaxy. Suddenly, the stars above don't just seem like distant points of light, they are revealed as active neighborhoods, places where material can be ejected, lost, and shared across the cosmos. There's something humbling about knowing that as we live our daily lives, cooking dinner, commuting to work, scrolling through our phones, a visitor from another star is silently racing through our solar system. It reminds us how small, and yet how lucky, we are to catch even a glimpse. After the first glimpse came the race. Every telescope that could point at 3I Atlas was called upon. Observations in visible light, infrared, and even radar were attempted. Professional astronomers worked alongside dedicated amateurs, pooling data to refine its orbit and understand what could be learned before the object slipped back into the void. Each observation was like adding another piece to a puzzle. The faint changes in brightness hinted at whether it was rotating or tumbling. The color of reflected light gave clues about whether its surface was icy, rocky, or coated in cosmic dust. And its orbit, tracked night by night, helped confirm just how unbound it was, ruling out any chance it was a long-period comet from our own Oort cloud. For the public, the first images of 3I Atlas were nothing more than faint smudges against a starry backdrop. And yet, the knowledge behind those smudges made them magical. They were proof of a connection across interstellar distances. That little dot was not ours. It was a traveler that had crossed unimaginable gulfs of empty space, perhaps millions of years in the making, only to be noticed in the brief instant it passed close enough for human eyes to detect. And so, the first glimpse of 3I Atlas was more than just an astronomical event. It was a reminder of the universe's openness. The solar system is not an island, sealed off from the rest of the galaxy. It is porous, open to visitors, and part of a much larger exchange of material between stars. As telescopes followed the faint dot deeper into the night, the story of 3I Atlas had only just begun. But those first few days, the discovery images, the orbit calculations, the worldwide excitement, set the tone for everything that followed. We had found, once again, that our corner of the galaxy is not isolated. We share it with wanderers, drifters, and messengers from afar. And by catching them in the act of passing through, we get a rare chance to learn not just about them, but about the vast galaxy that surrounds us. In the next section, we'll step back and explore what it means for an object to be a messenger from interstellar space, and why such discoveries are rewriting our understanding of cosmic wanderers. When astronomers looked at the faint streak of light called 3I Atlas, they were not just watching a rock, they were watching a message. Not a message written with words, letters, or symbols, but a message written in matter, in dust, ice, and stone, carried across interstellar space for perhaps millions or even billions of years. To understand why this matters, let's slow down and think about what interstellar really means. Our sun is not alone. It is just one star in a galaxy of hundreds of billions. Around those stars are planets, moons, and countless smaller bodies. Asteroids, comets, icy fragments, and dusty belts. Most of those stay bound to their home systems, circling endlessly, never leaving. But every so often, gravity gives one of them a push, a close pass by a giant planet, or a violent collision, or even the birth of a star itself can fling material so hard that it escapes forever. Those fragments become interstellar wanderers, cast adrift between the stars. And once they are set loose, They can travel for ages. No fuel needed, no destination in mind. Just endless flight across the black. Most of them will never be noticed by anyone. They are too small, too dim, too lost in the vast dark. But every once in a while, one happens to pass near another star system, like ours. And if that star system happens to have curious, watchful creatures with telescopes, that visitor becomes more than just a rock. It becomes a messenger. The word messenger might sound poetic, but it fits perfectly. Imagine a bottle tossed into the sea, drifting for years until it washes up on a distant shore. The bottle doesn't speak, but the fragments inside, a scrap of paper, a piece of handwriting, even the type of glass, tell a story of its origin. In the same way, interstellar objects are like bottles adrift on the cosmic ocean. Their shape, their chemistry, their motion, all carry clues about the stars and systems that made them. 3I Atlas might tell us what kinds of collisions are common in other systems. Its icy or dusty surface might reveal whether water-rich bodies form far away from alien suns. Its speed and path might hint at which direction in the galaxy it came from. Every detail is a clue. Every measurement is a word in the story. You might be wondering, if there are billions of stars, shouldn't interstellar objects be common? The answer is yes and no. Scientists estimate that our galaxy could be filled with trillions of wandering fragments. But space is so unimaginably big that only a tiny fraction ever cross our neighborhood. And of those, only the largest and brightest are detectable with our current technology. To put it in perspective, picture yourself standing in a desert, looking for individual grains of sand blowing across the horizon. They are out there, millions of them, but your eyes can only spot the few big ones that happen to glint in the sunlight. That is what astronomers face when searching for interstellar objects. They are probably everywhere, but only rarely do they shine bright enough for us to catch. That's why 3I Atlas is so precious. Each one we detect is like finding a needle in a haystack, or perhaps more like finding a pearl in the depths of the ocean. One of the most fascinating ideas about interstellar messengers is that they are part of a grand exchange. Imagine every star system in the galaxy as a workshop, constantly making, breaking, and reshaping worlds. Asteroids collide, comets evaporate, planets migrate and shift, and in all that chaos, pieces are flung away. Over millions of years, those pieces wander until they drift into other systems. This means that the solar system itself is not sealed off. It is part of a galaxy-wide flow of material. Some scientists even wonder if this exchange might have played a role in the story of life. Could icy comets from other stars have carried simple molecules into our system long ago? Could fragments of Earth, blasted away by impacts, have sailed outward to land one day on distant alien shores? If so, then interstellar messengers are not just curiosities. They might be part of the hidden threads that link life, matter, and history across the Milky Way. Before 3I Atlas, we had two earlier messengers. The first was 1I Oumuamua, discovered in 2017. Unlike anything we'd seen before, it was strangely elongated. Some said cigar-shaped, others imagined it like a flat shard of rock. It reflected sunlight in unusual ways and seemed to accelerate slightly as it left, as though pushed by invisible forces. Some thought it was just outgassing like a comet. Others wondered about exotic explanations. Whatever it was, it showed us that interstellar visitors could be very different from our familiar comets. The second was 2I Borisov, discovered in 2019. This one behaved more like a normal comet, trailing gas and dust as it neared the sun, glowing with a faint greenish haze. It reassured astronomers that not all interstellar objects were mysterious oddities. Some looked like cousins of the icy bodies we knew well. So when 3I Atlas arrived, the big question was, which family would it join? Would it be strange and puzzling like Oumuamua, or more comet-like like Borisov, or perhaps something entirely new? Another chapter in the growing story of cosmic messengers. There is also another side to these discoveries, one less scientific, but just as important. People feel wonder when they hear about objects like 3I Atlas. Children ask if it could be a spaceship. Adults wonder if it carries signs of life. Philosophers think about what it means to live in a galaxy where fragments are constantly trading places. This sense of wonder matters. Science is not just about data, it is about meaning. A single faint dot on a telescope image can stir feelings that remind us we are part of a living, changing universe. For a moment, we realize that the Earth is not an isolated stage. It is a port on a cosmic sea where travelers sometimes pass. The sad part of the story is that interstellar messengers never linger. They arrive quickly, slip through the inner solar system, and are gone again, sometimes within months. No matter how much we want to hold on to them, they are travelers, not residents. 3I Atlas will do the same. It will pass, leaving only our observations, our charts, and our imagination to remember it by. But in another sense, that fleetingness is what makes it beautiful. It is like watching a shooting star streak across the sky. The fact that it lasts only a moment makes us cherish it more. Imagine a message arriving at your doorstep, but with no return address. The paper is old, the ink faded, and you know it has traveled a very long way. You want to know where it came from. Was it sent by a neighbor from across the street, or by someone on the other side of the world? To answer, you would examine every clue. The kind of paper, the style of handwriting, the postmarks. Astronomers face a similar challenge with an interstellar messenger like 3I Atlas. They have in their hands a streak of light, a moving dot in the sky. It's slipping past our sun, vanishing quickly. If they want to know its origin, they must act fast. They must trace its path not just forward, to see where it's going, but backward into the past, to imagine where it may have been born. This detective work is part science, part art, and part imagination. Let us travel slowly through the process, as though we are sitting beside the astronomers, watching them connect dots across the heavens. The first step is simple. Watch it move. Stars, from our point of view, look fixed. They shift only slowly over centuries, but a wandering body like 3I Atlas glides against that starry backdrop from night to night. Each position is measured carefully, precise coordinates on the sky. With enough points, scientists can draw its trajectory, like sketching the arc of a thrown ball. But unlike a ball on Earth, this arc is not curved by air or ground. It is shaped by gravity, first the pull of the sun, then the nudges of planets, and behind that curve is a story of speed. 3I Atlas was already moving too fast to be bound. Even before entering our solar system, it carried enormous momentum, more than any of our planets or comets could give it. That excess speed told astronomers, this object is not one of ours. Once that truth was clear, the real detective work began. In physics, equations can run both ways. If you know how something is moving now, you can calculate where it will be in the future. But you can also rewind, step by step, to see where it came from. Astronomers did exactly this with 3I Atlas. They took its current path, its speed, and the gravitational map of the solar system, and they wound the clock backward. Like rewinding a film reel, they imagined the messenger's approach, slipping past Neptune's orbit, gliding inward through the scattered belt of icy rocks, brushing past Jupiter's far influence, and finally into the reach of our telescopes. Each calculation took it further back, until it was free of our sun's grip entirely. At that point, the question became, which direction in the galaxy was it traveling from? This may sound straightforward, but in truth, it is very hard. Why? Because space is not empty stillness. Every star you see in the night sky is moving. Some race in wide loops around the galactic center, others drift more slowly, and each travels at its own angle. When astronomers try to trace 3I Atlas backward, they must not only rewind the object itself, but also rewind the stars, entire constellations shifting slowly back into their past positions. It is like trying to trace the path of a leaf floating in a river, while also remembering that the river itself is flowing, meandering, and changing banks. The result is that pinning down a birthplace is almost impossible with our current knowledge. The best astronomers can do is estimate the general region of sky from which it came. For 3I Atlas, those calculations pointed roughly toward the direction of the Hercules constellation, a patch of stars about halfway between the bright northern lights of Vega and Arcturus. But from Hercules does not mean it was born there. It only means that, far back in time, its path seems to align with that region. It might have been flung from a star system billions of years ago, then drifted through the Milky Way, passing close to other stars, tugged by faint gravity until its direction shifted. By the time it reached us, its trail was not a straight arrow, but a line bent and curved by countless encounters. This brings us to one of the most fascinating possibilities: stellar flybys. As stars move around the galaxy, they sometimes pass relatively close to one another. Close in cosmic terms, meaning perhaps a light year or two apart. When that happens, the gravity of one star can disturb the outer debris of another. Icy comets, fragile asteroids, even loose planets can be nudged free, tossed into interstellar space. So, when astronomers say 3I Atlas may have come from near Hercules, what they really mean is that somewhere, long ago, perhaps a star passed near another, and in the chaos a fragment was launched. That fragment is what we see now. It is astonishing to think. 3I Atlas could be a shard of a planetesimal disk circling some forgotten star. Perhaps it once orbited a small red dwarf. Perhaps it was shattered in a collision. Perhaps it lingered in that system's outskirts until a passing giant star tore it loose. And then, off it went, crossing gulfs of darkness for tens of millions of years before arriving in our sky. Why spend so much effort tracing its path? Because direction carries history. If we can connect an interstellar object to a specific star or region, we can learn about that system's architecture. Was it rich in icy bodies, like our own Kuiper Belt? Did it fling material outward violently, perhaps hinting at giant planets that reshaped its orbit? Even without a clear origin, the direction tells us about the density of such wanderers in different galactic regions. If, in the coming decades, we spot many more coming from similar directions, we might discover that certain parts of the galaxy are hotspots for ejecta, regions where stars are young and chaotic, throwing off fragments like sparks from a fire. But tracing the path is not only about numbers, it is about perspective. When astronomers stare at 3I Atlas's trajectory, they are not just plotting lines on a graph. They are imagining history on scales almost too large to grasp. Think about it. When the object was first launched, Earth itself might not have looked the way it does today. If it was ejected a billion years ago, our world would have been a planet of single-celled organisms, long before forests, animals, or people. That means 3I Atlas has been traveling while entire civilizations of life rose and fell, while continents drifted, while oceans formed and vanished. It is a time traveler carrying memories older than our species. That realization makes the tracing even more moving. It is not only a technical puzzle, but also a reminder of deep time, of how small our own stories are compared to the wanderings of matter in space. Let's pause and picture how this detective work is actually done. The astronomers do not sit with pencils and paper. They use powerful supercomputers that can simulate the movements of millions of bodies at once. These machines crunch numbers faster than any human mind could manage, calculating gravitational pulls, orbital angles, and uncertainties. The result is not a single path, but a cloud of possible paths. Imagine throwing a handful of pebbles into the air. Most will land in roughly the same area, but some will bounce differently. In the same way, astronomers generate many possible backward trajectories for 3I Atlas, each slightly different depending on tiny errors in measurement. The overlapping region of those paths gives them their best guess. Even then, the answer is blurred. Perhaps it came from the Hercules region, or perhaps from somewhere nearby. The truth remains hidden in the haze of time. If you step back, tracing interstellar messengers is about more than curiosity. It is part of building a map of the invisible connections between stars. Every traced path is a thread linking one system to another. Together, those threads form a web of exchange, showing how no star is truly isolated. This matters for our own sense of belonging. Humans often imagine stars as distant, lonely lights. But tracing reveals a different truth. Stars are participants in a grand circulation of matter. Rocks, ices, and maybe even seeds of life wander between them. Our solar system is not a sealed box, but a port in a cosmic network. Now, close your eyes for a moment and picture it. A single icy fragment, no larger than a mountain, drifting for eons. It passes stars we cannot name. It sees nebulae glowing in colors our eyes will never see. Then, by pure chance, it approaches our sun. And for a few months, humanity notices. Telescopes swing toward it, cameras capture it, children hear about it in classrooms, poets write about it. Then it is gone again, slipping outward, never to return. Tracing its path is not only science, it is our way of honoring the moment. It is how we say, "We saw you, we tried to know you, we will not forget." Imagine you've traveled for millions of years across a silent, endless ocean. You are small, fragile, and ancient. You have survived collisions, cosmic rays, and the emptiness between the stars. Then, finally, you reach a new system, a place of warmth, light, and gravity. But the very sun you approach, the one that could reveal your secrets to curious watchers, becomes the force that unravels you. That is the fate of 3I Atlas, our fragile visitor from beyond the stars. Unlike its predecessors, it never completed its journey through the inner solar system. Instead, it began to break apart before we could fully learn its story. When astronomers tracked 3I Atlas in early 2020, they noticed something strange. Its brightness, instead of following the usual smooth pattern of a comet, began to flicker and spike. At first, this was exciting. A sudden increase in brightness could mean dramatic outgassing, jets of gas and dust spraying into space as sunlight heated its icy surface. But soon, the pattern shifted from exciting to troubling. The spikes were irregular, chaotic. It looked less like a comet's steady breathing and more like a heart skipping beats. Then, the telescope images grew fuzzier. The neat dot of light stretched into a blur, as though the comet was smudging itself across the sky. Astronomers realized the truth. 3I Atlas was disintegrating. To understand why, we need to think about what comets and interstellar visitors like 3I Atlas are made of. They are not solid rocks like planets. They are more like cosmic snowballs, loosely packed mixes of ice, dust, and organic material. Some astronomers even call them dirty snowballs. Over time, as a comet approaches a star, heat causes the ices to vaporize. That process is what creates a glowing tail. But the same process can weaken the structure. If the comet is already fragile, cracked from collisions long ago, or held together only loosely, the warming can be too much. Pressure builds inside as gas tries to escape. Eventually, the fragile shell shatters. For 3I Atlas, that moment came as it drew closer to the sun. The heat and pressure were too much for its ancient body. It fractured into pieces, scattering its story into dust before humanity could gather it all. This might sound tragic, but it is not unusual. Many comets in our own solar system have met the same fate. For example, Comet Shoemaker-Levy 9 broke apart spectacularly in 1992 after passing too close to Jupiter's gravity. Its fragments later slammed into Jupiter's atmosphere in 1994, creating fiery scars the size of Earth. Comet Ison, a dazzling comet spotted in 2012, disintegrated as it grazed the sun in 2013, leaving nothing but dust behind. Even famous comets like Halley's Comet shed large amounts of material every pass, gradually wearing down over millennia. So 3I Atlas was not unique in breaking apart, but what made it heartbreaking was that it was an interstellar visitor, one of only 3 we had ever seen. Its early death meant we lost a rare chance to study it in detail. Even though it broke apart, 3i Atlas still taught us things. Telescopes captured its changing brightness, its jets of dust, and its fragments spreading outward. Those fragments told scientists that it was fragile, perhaps even more fragile than typical solar system comets. That could mean it had spent billions of years drifting in the interstellar dark, unprotected, slowly eroded by cosmic radiation. Its motion also confirmed that it was truly interstellar. Despite the breakup, its hyperbolic trajectory remained clear. It was never bound to the sun. It had come from beyond, and it would leave again, even if only as a cloud of dust. There is a quiet kind of poetry in the way 3i Atlas ended. We often imagine space as eternal, full of unchanging rocks and stars. But the truth is more delicate. Even ancient wanderers can crumble. Even cosmic messengers can lose their shape. In a way, its fragility reminds us of ourselves. Human beings are small, temporary creatures. We, too, are fragile against the vastness of time and space. And yet, like 3i Atlas, our brief existence carries meaning. Its short visit reminded us that even fleeting messengers can open windows into the unknown. Some scientists and dreamers wondered if the breakup meant we missed deeper secrets. Could 3i Atlas have carried exotic ices we never measured? Could its fragments have held rare molecules from distant stars? Might it have been as strange as Oumuamua, if only it had survived intact? These questions can never be answered fully. The data we gathered is all we have, but perhaps that mystery itself is part of the story. In science, every discovery is also a reminder of what we do not yet know. The gaps inspire us to keep searching. The death of 3i Atlas also highlights a universal truth. Impermanence is everywhere. Stars burn out, planets erode, galaxies collide and change shape. Even the universe itself is evolving. Nothing, not even an interstellar traveler, lasts forever. But impermanence is not loss. It is transformation. The dust of 3i Atlas will not disappear. It will simply spread out, becoming part of the solar system's space environment. Tiny grains may drift for centuries, perhaps even falling into Earth's atmosphere as meteors, burning brightly for a moment before fading. In this way, the messenger still speaks, not as a whole body, but as countless sparks scattered across the sky. For us, 3i Atlas is more than a scientific note in a journal. It is a reminder of the value of fragile things. Sometimes we cherish something more because it is fleeting, like a snowflake, like a sunset, like a comet breaking apart before our eyes. Beauty often lies in impermanence. When we look at the blurry images of its fragments, we are not just seeing dust. We are seeing a story that began around another star, traveled across interstellar space, and ended here, briefly, in our sight. When something drifts into our solar system from another star, you would expect astronomers to have a clear answer. What is it? But with interstellar objects, clarity is rare. Instead, mystery clings to them, as though they bring with them the shadows of the deep space they crossed. With 3i Atlas, the debates began almost immediately. Some scientists saw a fragile, icy comet behaving in a predictable way, breaking apart under solar heat. Others saw hints that something stranger might be hiding in its story. Let's step carefully into those debates, listening not just to the facts, but also to the questions that keep echoing. The first big question was simple. Was 3i Atlas a comet or something else? At first glance, it behaved like a comet. It released gas and dust, brightened as it neared the sun, and even developed a faint tail. These were classic cometary features. So many astronomers concluded quickly, yes, this was an interstellar comet, more like Borisov than Oumuamua. But others noticed peculiarities. The brightness of 3i Atlas rose and fell erratically. Its disintegration came faster than expected. Even its tail looked oddly uneven at times. Was it simply an extremely fragile comet, or was there more to the story? This uncertainty reminded many of the mystery of Oumuamua, the first interstellar visitor. That one had looked like an asteroid, no tail, no gas emissions, yet it moved in ways that suggested some hidden force, maybe outgassing, maybe something stranger. Compared to Oumuamua, 3I Atlas seemed more ordinary, but astronomers could not ignore its unusual behavior. One of the biggest mysteries was its light curve, the way its brightness changed over time. Most comets brighten smoothly as they get closer to the sun. Imagine lighting a candle and watching the flame grow stronger as the wax melts. But 3I Atlas flickered like a candle in the wind. Its brightness spiked unpredictably, then dimmed, then spiked again. Some scientists thought this meant large chunks were breaking off, exposing fresh ice that briefly flared with reflected sunlight before fading. Others suggested uneven jets of gas, like geysers erupting from different spots, could be causing the flickers. Still, some wondered, could the brightness changes be telling us something about its surface composition? That it wasn't just ordinary water ice, but something more exotic? One line of debate focused on what kind of ices 3I Atlas might have carried. In our own solar system, comets are full of familiar materials: water ice, carbon dioxide ice, carbon monoxide ice, and dust. But in another star system, conditions might be very different. Could 3I Atlas have been made of something unusual? Some scientists speculated about super volatile ices, materials that vaporize at extremely low temperatures, like nitrogen or carbon monoxide. If 3I Atlas had lots of those, it would explain why it seemed so fragile and active, even far from the sun. Others were more cautious. The data we gathered, they argued, fit within the range of normal comet behavior. The idea of exotic ice was tempting, but without direct measurements, it was impossible to prove. Sometimes, scientists reminded themselves, the universe gives us strange stories. But sometimes it only looks strange because we caught a fleeting, incomplete glimpse. Although most agreed that 3I Atlas was comet-like, a small group of astronomers raised an intriguing question. What if it was hiding a kinship with Oumuamua? Oumuamua had puzzled scientists because it accelerated slightly as it moved away from the sun, even though no tail or outgassing was visible. Some theorized that it might have been shedding thin sheets of hydrogen ice or nitrogen ice, substances too faint for telescopes to see. Could 3I Atlas, in breaking apart, offer a clue to what Oumuamua had been? If both were fragile bodies shedding exotic ices, maybe interstellar space regularly produces such delicate messengers. If so, then fragility might be a common signature of interstellar travelers. Of course, hovering at the edge of every debate was the boldest question of all. Was 3I Atlas artificial? When Oumuamua passed through, a few scientists, most famously Avi Loeb, suggested it might be alien technology, perhaps a thin solar sail drifting between stars. Most astronomers disagreed, preferring natural explanations, but the idea sparked public imagination. With 3I Atlas, the artificial hypothesis was quieter. After all, it looked and acted more like a comet than Oumuamua ever did. Still, the whispers were there. If advanced civilizations existed, could they send fragile probes disguised as comets? Could disintegration even be intentional, like a seed pod scattering material? Most scientists dismissed these ideas as speculation without evidence, but even they admitted, the very fact that we must ask shows how much we still don't know about interstellar visitors. When 3I Atlas broke apart, astronomers hoped its fragments might tell us more. If a comet splits, the pieces sometimes reveal different layers of its interior, like slicing open a cake to see the layers inside. But 3I Atlas crumbled too quickly, and its pieces were too faint to study in detail. We saw only fuzzy smears of dust, no sharp details. That made the mystery deeper. Was it so fragile because of its composition, or because of damage it had suffered during its long journey? Another theory was that 3I Atlas had simply aged poorly. Imagine drifting for millions of years between stars, constantly bombarded by cosmic rays. Over time, the surface of such a body could become brittle, cracked, weakened. By the time it entered our solar system, it might have been little more than a shell, ready to crumble at the first touch of sunlight. If this was true, then maybe all interstellar comets are fragile, and if so, then 3I Atlas's death wasn't unusual at all. It was simply a preview of what we should expect when more arrive. In the end, debates about 3I Atlas were less about firm answers and more about possibilities. Was it an ordinary comet or an extraordinary one? Was it full of exotic ice or just fragile dust? Was it a cousin to Oumuamua or a completely different kind of traveler? We may never know. Its quick disintegration left us with far fewer clues than we hoped. Yet, in a way, that is what makes it unforgettable. Like a whispered message carried on the wind, it gave us only fragments, forcing us to lean in closer, to wonder, to debate. For astronomers, mysteries like this are both frustrating and thrilling. Science is built on data, and 3I Atlas gave us only scraps. But those scraps were enough to spark imagination, theories, arguments, and dreams. And for ordinary people, the ones who looked up at the night sky and learned there was an interstellar visitor passing overhead, the mystery itself was enough. You don't always need clear answers to feel awe. Sometimes the questions are the gift. When we talk about 3I Atlas, we cannot do so in isolation. To truly understand its meaning, we must place it beside the other rare interstellar travelers we've seen, Oumuamua and Borisov. Together, these three objects form a kind of cosmic trilogy, 3 acts in a play where the stage is our solar system and the audience is us, watching with wide eyes as visitors from the stars drift briefly into our sight. In 2017, astronomers in Hawaii spotted something strange slicing through the solar system. It was small, faint, and moving far too fast to belong here. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. What made Oumuamua so fascinating was its shape and behavior. Unlike comets, it showed no clear tail of dust or gas, and yet it accelerated slightly as it left the sun, as if something invisible was pushing it. The object itself was incredibly elongated. Some estimates suggested it was up to 10 times longer than it was wide. Was it a thin shard of rock, a flattened disk, a cosmic pancake? Nobody knew for certain. This odd behavior sparked wild debates. Some argued it was a natural fragment from a distant planet. Others suggested exotic hydrogen ice or nitrogen ice that evaporated in ways we didn't understand. A few even whispered, what if it was artificial? A derelict probe from another civilization, sailing silently through the stars. The truth is still unknown. Oumuamua remains one of the great astronomical puzzles of our time. 2 years later, in 2019, another interstellar visitor appeared, Comet Borisov. Unlike Oumuamua, Borisov looked familiar. It had a fuzzy coma, a glowing tail, and the telltale chemistry of comets we knew from our own solar system. But Borisov was also unique. Its tail was unusually long, stretching millions of kilometers, and its composition hinted at high levels of carbon monoxide, perhaps more than typical local comets. That suggested it had formed in a colder environment than our solar system, maybe near the icy edge of another star's system, where gases like carbon monoxide could freeze solid. In Borisov, astronomers found confirmation. Yes, other planetary systems make comets much like ours. Comets are not just local quirks. They are a cosmic tradition, born wherever stars and planets form. Then came 3I Atlas, discovered in 2020. At first, it looked like Borisov, a comet with a tail, a visitor from afar. But then it betrayed its own fragility, breaking apart before it could reach its closest point to the sun. Its fate made it different from both Oumuamua and Borisov. It was neither as strange as the first, nor as stable as the second. Instead, it was a story of impermanence. Together, these 3 interstellar visitors paint a spectrum of possibilities. Oumuamua, mysterious, solid, and unlike anything we had seen before. Borisov, familiar, comet-like, a reassuring echo of home. 3I Atlas, fragile, unstable, a reminder of the vulnerability of ancient objects. When we compare them, something becomes clear. Interstellar objects are not one kind of thing. They are a diverse family. Some may be shards of rock, flung out by violent collisions. Others may be icy comets, ejected from the outer reaches of alien star systems. Some may survive their long journey intact, while others crumble under the stress of a new sun's warmth. This diversity tells us that the galaxy is full of debris. Every planetary system, ours included, is constantly shedding material into interstellar space. Over billions of years, the stars have been trading fragments, as if exchanging postcards across light years. When one of these fragments passes through our neighborhood, we are catching a glimpse of that great galactic mail system, shape and stability. Oumuamua was rigid and elongated, while 3I Atlas was fragile and broke apart. This contrast suggests different origins. One may have been a fractured shard of rock, the other a loosely bound comet. Behavior. Near the Sun, Borisov and Atlas both outgassed, creating tails, but Borisov remained intact, while Atlas disintegrated. Oumuamua showed no tail but still moved oddly, hinting at subtle forces like outgassing of invisible ices. Compositional clues. Borisov's chemistry revealed exotic ices. Atlas's fragments hinted at extreme fragility. Oumuamua revealed almost nothing, leaving behind more mystery than data. It is also worth noticing how we reacted to each visitor. With Oumuamua, the world was stunned. It was the first interstellar object ever confirmed, and it ignited our imaginations. With Borisov, the mood was calmer, more scientific. By then, we knew interstellar visitors existed. Borisov reassured us that other systems were not so different from our own. With 3I Atlas, the reaction was more reflective. Its breakup reminded us of the fragility of such encounters. By then, the world was also in the grip of the COVID-19 pandemic. The crumbling of a fragile visitor may have felt like a mirror to our own vulnerabilities at the time. Comparing these three messengers, we see not just science, but philosophy. Oumuamua showed us that the universe can surprise us with the utterly strange. Borisov showed us that we are part of a larger pattern, not alone in making comets. And 3I Atlas showed us that impermanence is part of every cosmic story. Together, they remind us of three truths. The universe is stranger than we expect. The universe is more familiar than we fear. The universe is more fragile than we realize. Astronomers are now preparing for the next visitors. Telescopes like the Vera C. Rubin Observatory in Chile, set to begin operations soon, will scan the skies with incredible sensitivity. It may discover dozens, even hundreds, of interstellar objects in the coming decades. Some will be rocky, some icy, some whole, and some in pieces. Each one will add to the picture, and perhaps one day, humanity will be ready not just to watch, but to reach out. Imagine a future where a spacecraft is launched quickly enough to intercept an interstellar visitor, flying alongside it, measuring its gases, mapping its surface, maybe even collecting a sample. That would be like shaking hands with another star system. Until then, we will continue to compare and wonder, watching as each brief messenger passes through our cosmic stage. When you imagine the universe, it's easy to picture stars standing still, each one surrounded by neat planets circling in quiet harmony. But reality is far wilder. Star systems are not perfectly balanced clockwork machines. They are messy, chaotic, and dynamic. And this chaos is the very reason why we sometimes find fragments of those systems, comets, asteroids, even larger bodies, hurtling into interstellar space. This process is often called gravitational ejection, and it is one of the most important ideas for understanding interstellar visitors like 3I Atlas. To put it simply, planets and stars are constantly acting like giant bumpers in a cosmic pinball machine, slinging small objects around with incredible speed. Most of the time, the objects are caught in orbits, but sometimes they are flung so hard that they escape their home star entirely, doomed, or perhaps blessed, to wander forever between the stars. Let's settle in and slowly explore how this works. Gravity is the universal puppeteer. Every planet, moon, and comet is tugged upon by every other object. In a stable system, these tugs mostly balance out. A planet circles its star year after year, repeating its path like a record spinning endlessly on a turntable. But things are never perfectly stable, especially in the early days of a planetary system, when planets are still moving into their places. Their orbits cross and shift. Picture a crowded playground where children are running in circles with no set rules. Occasionally, one child bumps into another, changing direction or speeding up. In space, bumping doesn't mean colliding. It usually means a close gravitational pass, where one body slingshots another. If a small object, like a comet or asteroid, passes near a giant planet, something remarkable happens. The planet's gravity can accelerate the smaller body. This is the same principle spacecraft engineers use when they send probes to the outer solar system. By swinging past Jupiter or Saturn, a spacecraft can steal a little energy from the planet's orbit and use it to slingshot outward at enormous speed. Now imagine this happening to comets over and over. One close pass by Jupiter may fling a comet into the inner solar system. Another pass might toss it outward again. With just the right alignment, one of these encounters can give the comet enough energy to escape the sun entirely. The comet becomes unbound, leaving home forever. This is not rare. In fact, it is estimated that during the early history of the solar system, trillions of icy bodies were ejected this way. They now drift silently between the stars, each one carrying within it the history of the place it came from. Not all planets are equally skilled at ejecting material. The champions are the giant planets, Jupiter, Saturn, Uranus, and Neptune in our solar system. Their immense mass gives them the strongest gravitational slingshot. Jupiter, especially, is the great gatekeeper. Sometimes it defends the inner solar system, sucking in comets and asteroids that might otherwise hit Earth. Other times, it flings those same objects outward at such high speed that they are lost forever. You could say Jupiter is both protector and exile maker. Without it, our solar system might have been far more dangerous to life, bombarded endlessly by comets. With it, countless objects have instead been cast into interstellar space, never to return. And just as our Jupiter does this work, so too must other giant planets in other star systems. Whenever a planetary system forms with large worlds, they will act as cosmic bouncers, tossing smaller visitors out of the club of their home star and into the cold streets of interstellar night. If today's solar system seems relatively calm, it wasn't always so. Billions of years ago, the planets were still shifting into position. Some scientists believe Neptune and Uranus may not have formed where they are today, but migrated outward. In this chaotic migration period, countless icy bodies from the outer disk were disturbed. Many were flung inward, bombarding the young Earth and Moon. Many others were thrown outward, some into distant stable orbits like the Oort cloud, and others entirely out of the Sun's gravitational grip. This great ejection period may have filled the galaxy with wandering debris from our system alone. Now multiply that by the hundreds of billions of stars in the Milky Way, and you begin to realize interstellar space must be littered with untold trillions of wayward comets and fragments. Each star is a factory, and the galaxy is its showroom floor. The story doesn't end when an object leaves its home star. Space is not empty of gravity. Stars tug at one another across light years. Passing stars can disrupt comet clouds. A rogue object drifting close to another star may find itself deflected, slowed, or even captured. In this way, the galaxy is not just a pinball machine, but a sprawling arcade of machines connected together. A comet that starts in one system may spend millions of years drifting, only to someday wander into another star's influence. This is how 3I Atlas, Borisov, and Oumuamua likely came to us, cast away from their birth systems and sent on long, lonely journeys until they briefly cross paths with our Sun. It is poetic to think of this process as a mail system of the stars. Each ejected comet is like a letter, sealed long ago, carrying chemical messages from its place of origin. When one drifts into our solar system, it's as if we've received a postcard from another world. Borisov told us that comets form with exotic ices in far colder places than Earth. Oumuamua whispered mysteries we still cannot explain. Atlas reminded us how fragile these cosmic messengers can be. Every visitor brings new information, written not in ink, but in dust, ice, and orbit. Not every object survives this game. Many are torn apart during ejection, broken by tidal forces or shattered in collisions. Others endure but wander in the darkness until they decay. Those that last long enough to pass near another star are rare jewels, and catching even a glimpse of one is an extraordinary privilege. Atlas showed us this fragility firsthand. Its breakup demonstrated the harsh reality. Not every interstellar object is built to last. Some crumble at the first touch of heat from a new sun. Others may arrive as little more than ghostly dust clouds, never noticed at all. The cosmic pinball machine is not just a curiosity. It may also be a mechanism for spreading life. Some scientists have wondered whether hardy microbes, locked inside protective rocks, or icy comets, could survive ejection and travel across interstellar distances. If so, then planetary systems might not only be exchanging rocks, but also seeds of biology. This idea, called panspermia, is controversial. But even if life itself does not spread this way, the raw materials for life, organic molecules, water ice, complex carbon chains, certainly do. Interstellar objects are like delivery packages, scattering the ingredients of chemistry across the galaxy. It is humbling to realize that we are part of this same pinball game. Earth itself has been struck countless times by objects nudged inward by Jupiter. Some of these impacts may have brought water to our planet. Some may even have delivered the molecules that eventually built life. And Earth, too, has probably sent material outward, chunks blasted off by asteroid impacts that drift into the void. Perhaps fragments of our own world now wander among the stars, silent ambassadors of a planet alive with oceans and forests. As we watch the skies with better telescopes, we will catch more of these interstellar travelers. With each discovery, we add another piece to the puzzle of the galactic pinball machine. And one day, perhaps, we will not only watch them pass, but intercept them, study them up close, and maybe even bring a piece back to Earth. Until then, we sit in awe, knowing that every interstellar visitor is the end of a long journey. A journey that began in the crowded, chaotic nursery of another star, where gravity played its game and chose who stayed and who was cast out into the infinite dark. For thousands of years, humans have looked up at the sky and wondered if the stars had something to say. We saw patterns in constellations, stories in the dance of planets, omens in comets. Some cultures feared these glowing visitors. Others worshipped them as divine messengers. But in modern times, with telescopes, math, and physics, we've discovered something even more profound. Sometimes those messengers are not just from our solar system. Sometimes they come from other stars entirely. And when they do, they don't just teach us about space. They teach us about ourselves. In this section, let's lean back, breathe slowly, and walk through the lessons that interstellar visitors like Oumuamua, Two-Eye Borisov, and Three-Eye Atlas whisper to humanity. These lessons aren't written in stone. They're scattered in dust tails, glimmers of light, and the fleeting arcs of fragile travelers. But if we listen carefully, the lessons are loud enough to echo across centuries. Humans have always known the universe is big. Ancient sailors navigating by the stars already felt the weight of its immensity. Astronomers like Copernicus, Galileo, and Kepler taught us our place was not at the center. And Hubble showed us entire galaxies beyond our own. But the arrival of the first interstellar object in 2017, Oumuamua, made that vastness personal. It wasn't just that the galaxy is full of stars and planets. It was that chunks of those systems, leftovers, rejects, fragments, can wander across the void and pass right through our neighborhood. It's a little like realizing your house isn't on a quiet street after all, but at a busy cosmic intersection with occasional visitors who don't bother to knock. This lesson humbles us. We like to imagine the solar system as an island, neat and self-contained, but interstellar messengers remind us we are part of a larger ocean, and currents from afar will always wash ashore. Take Three-Eye Atlas, It crumbled before we could fully study it. To some, that might seem like a wasted opportunity, but in its fragility lies its meaning. Everything in the universe is temporary. Stars burn out, galaxies collide, even the atoms in our bodies will someday scatter. 3i, Atlas, didn't fail because it broke apart. It simply reminded us that impermanence is woven into reality. And yet, in that brief moment of existence, it sparked wonder, questions, and reflection. Just like a sunset lasts minutes or a snowflake melts in your palm, the beauty of interstellar visitors lies in their transience. Humans too are fragile and temporary. But that doesn't make our lives meaningless. On the contrary, it makes every act of kindness, every discovery, and every story we tell infinitely precious. When Oumuamua appeared, it looked so strange that some scientists, with very serious faces, asked whether it could be an alien spacecraft. Others proposed exotic hydrogen icebergs, giant dust pancakes, or even fragments of shredded planets. Were all those theories correct? No, but that wasn't the point. The point was that humanity looked, wondered, and asked. Our curiosity was not content with easy answers. And that curiosity is not just a luxury, it's survival. Without it, we would still be staring at fire instead of building rockets. Without it, we wouldn't even know interstellar objects exist. Every time we debate, every time we argue about a strange rock in the sky, we are sharpening the very skill that makes our species endure. Interstellar messengers whisper, keep asking, keep doubting, keep wondering. The dust of comets is not alien to us. In fact, much of Earth's water and organic molecules may have been delivered by comets long ago. The very carbon in your body, the oxygen you breathe, the calcium in your bones, all forged in distant stars, may once have traveled like interstellar messengers before finding a home here. So when we study 2i Borisov or 3i Atlas, we are not just studying them, we are in a sense studying ourselves. Imagine this. Somewhere around another star, a comet broke free and drifted for millions of years. Then it reached us, burned in our skies, and left us clues. In that moment, we and that distant star system are linked. We are threads in the same cosmic tapestry. This lesson humbles us. It reminds us that identity is larger than Earth or solar system. We belong to the galaxy. And maybe one day, our own fragments, probes, ships, or even comet-like debris will drift to other stars, carrying whispers of us in return. Scientists love answers. Humans in general like things tied up neatly. But interstellar objects often refuse to cooperate. Oumuamua didn't behave like a comet, but also didn't look like an asteroid. 2i Borisov looked more ordinary, but still puzzled astronomers with its composition. 3i Atlas fell apart too soon to be fully explained. These mysteries could be frustrating, but they also remind us that uncertainty is part of growth. When we admit we don't know, we open the door to new discoveries. If we had stopped at Oumuamua is just a rock, we wouldn't have uncovered debates about hydrogen icebergs or exotic interstellar chemistry. In life, too, uncertainty can feel uncomfortable, but it often hides opportunities. The unknown is not a wall, it's a doorway. Oumuamua was only a few hundred meters long. 2i Borisov wasn't much larger. 3i Atlas was fragile and short-lived. Yet their arrivals changed astronomy forever. Sometimes we imagine history is shaped only by grand events, supernovas, black holes, galaxy collisions. But small things matter. A pebble from another star system can shift the way we see the cosmos. In the same way, in human life, small acts, a smile, a kind word, a single spark of curiosity, can ripple across time and change everything. At the core of all this, interstellar visitors remind us of our oldest trait. We are storytellers. Ancient people told stories about comets as fiery dragons, divine swords, or harbingers of doom. Today we tell stories with equations, telescope images, and computer models. The tools changed, but the impulse is the same. We see a mysterious visitor, and we weave it into a narrative. Oumuamua became a story about alien probes. 2i Borisov became a story about cosmic kinship. 3i Atlas became a story about fragility. Each object is science, yes, but also myth, poetry, and metaphor. This lesson tells us something profound. No matter how advanced we become, humans will always frame the unknown in stories. It's how we make sense of the universe and ourselves. We spend a lot of time imagining leaving Earth to explore the stars, but interstellar messengers flip that perspective. Sometimes the stars come to us. This is oddly comforting. It means we don't always have to go chasing the unknown. Sometimes it arrives at our doorstep. Of course, we should still build ships and telescopes, but every once in a while, it's nice to remember the cosmos is not silent, it's knocking on our door. And when we open it, even briefly, we glimpse just how alive and dynamic the galaxy really is. The truth is, we almost missed Oumuamua. It was already on its way out by the time we spotted it. We barely glimpsed 3i Atlas before it crumbled. These events remind us that our technology, while powerful, is still limited. And that's good. Humility keeps us grounded. If we thought we had all the answers, we'd stop looking. Interstellar visitors remind us to stay humble, to admit how small we are in time, space, and knowledge. Humility, in science and in life, is not weakness. It is strength. It is the openness that lets us keep growing. Perhaps the greatest lesson of all is simple. Wonder matters. Not everything needs to have immediate utility. Not every discovery will fuel a new technology or save the world. Some things are valuable simply because they expand our imagination, stretch our sense of belonging, and remind us the universe is vast and mysterious. When we saw 2i Borisov's tale, when we puzzled over Oumuamua's strange shape, when we mourned 3i Atlas's breakup, we weren't just doing science. We were exercising the muscle of wonder. And in a busy, noisy world, wonder is worth preserving. When we look into the night sky, we don't just see dots of light. We see mysteries. We see stories. For thousands of years, human beings have looked upward and wondered if something, or someone, might be looking back. Every strange light, every comet, every visitor from beyond has sparked not only scientific questions, but also deep feelings, awe, fear, excitement, and the irresistible urge to explain what we see through stories. The interstellar visitors, Oumuamua, 2i Borisov, and 3i Atlas, are not the first messengers from the sky to capture our imagination. They are simply the most recent chapter in a much longer human history of turning cosmic strangers into meaning. In this section, we'll explore how humanity has always reacted to celestial visitors. We'll see how cultures across the world turned comets into omens, how ancient people imagined falling stars as spirits, and how modern society, even with telescopes and computers, still turns interstellar objects into fuel for wonder and storytelling. Because in the end, the science explains what these visitors are, but the stories explain why they matter to us. Long before astronomers gave us terms like hyperbolic trajectory or comet nucleus, people had only their eyes and their imaginations. The night sky was a canvas, and anything unusual that appeared on it was interpreted as a sign. To the Babylonians, comets and meteors were messages from the gods, often warnings of upcoming political or military events. A sudden bright streak might mean the rise or fall of a king. In ancient China, astronomers carefully recorded comets in bamboo scrolls. Some were called broom stars because of their long tails. These were thought to sweep away old dynasties or announce great change. In Europe during the Middle Ages, comets were feared as signs of plague or famine. When Halley's Comet appeared in 1066, people in England believed it foretold the Norman invasion and the defeat of King Harold at Hastings. These beliefs weren't silly. They were part of how people made sense of the unpredictable. When something rare appeared in the heavens, it was natural to connect it to rare events on Earth. The unknown in the sky mirrored the unknown in life. Visitors from space have always carried a double meaning, beauty and danger. A comet's glowing tail is breathtaking, yet its suddenness felt threatening to ancient eyes. Even today, that mix remains. When Oumuamua was first discovered in 2017, scientists measured its odd, elongated shape and unusual acceleration. The media quickly ran with headlines. Could it be an alien ship? Books, podcasts, and countless articles spread the idea. People felt both thrilled and unsettled. The thought of something artificial from another star was both awe-inspiring and a little scary. The same happened with Borisov in 2019. As the first confirmed interstellar comet, it filled people with wonder. A piece of another star system, right here in our telescopes. Yet beneath the excitement was another feeling. What else might be traveling through space unseen? Could larger, more dangerous visitors exist? What if one day a rogue planet or asteroid from beyond threatens Earth? That tension between joy and dread is the heartbeat of our connection to cosmic visitors. When 3I Atlas broke apart in 2020, scientists studied the fragments. But for many ordinary people, the story became a kind of parable. Something ancient and alien had traveled so far, only to crumble before reaching the sun. For some, that was disappointing. For others, it felt strangely poetic. It reminded us of our own fragility. Like Atlas, we humans are travelers, brief, delicate, subject to forces greater than ourselves. And yet, just like the comet, our short existence still leaves an impact. Even dust tells a story. This is why people didn't just read about 3I Atlas as science. They shared it as a metaphor. On social media, some wrote poems about it. Others used it as a symbol of endurance and loss during the pandemic year. The science gave us data, but the human spirit gave us meaning. Psychologists say humans are natural storytellers. We don't just want to know what happened. We want to know why it matters. When something strange crosses the sky, we don't simply say, "That's an object on a hyperbolic orbit." We say, "It must mean something," and in a way, we're right. Not in the literal sense of comets predicting kings, but in the emotional sense. These cosmic visitors do change us. They shape our culture, our imagination, and our sense of place in the universe. Think about it. Every child who sees a shooting star makes a wish. Every culture has myths about the heavens. Every generation rediscovers comets with fresh awe. These stories bind us together across centuries. Today, we live in an age of science, but myths haven't disappeared. They've just changed shape. Instead of gods and omens, we talk about aliens, spaceships, and first contact. Some people speculated that Oumuamua might be a probe, a scout sent by an advanced civilization. Harvard astronomer Avi Loeb even wrote a best-selling book arguing that possibility. Whether one agrees or not, the idea captured global attention. Movies like Don't Look Up and Deep Impact echo our fear of rogue comets, blending science with drama. Science fiction writers use interstellar objects as symbols of mystery, gateways to other worlds, carriers of hidden messages, even seeds of life itself. In other words, we still weave stories around the same sky phenomena. The language has changed, but the impulse is the same. Perhaps the most powerful part of these stories is how they act as mirrors. The way a society interprets a comet often reveals its deepest concerns. Ancient kingdoms worried about stability, so comets became omens of political change. Medieval Europeans feared disease and famine, so comets became signs of death. Today, we wonder about extraterrestrial life and planetary defense, so interstellar objects become questions of alien technology or cosmic threats. In every age, the visitor reflects us. It tells us more about our hopes and fears than about itself. Yet beyond fear, there is always wonder. A child seeing a comet streak across the sky does not think of omens. They think of magic. Adults may complicate it with science or dread, but the spark of awe remains the same. This wonder is not trivial. It is what drives exploration. Every mission to space, from the Voyager probes to the James Webb Space Telescope, began with someone looking up and saying, "What is that? I want to know." When we meet interstellar visitors like 3I Atlas, we are reminded of how big the universe is and how small we are, but also how curious we are. And curiosity is our greatest strength. Across cultures, times, and technologies, the pattern is clear. A strange object appears in the sky. People react with fear, awe, or both. Stories are told to explain it. Science eventually describes its nature. Yet the stories live on because they speak to the heart. This pattern is not unique to comets. It happens with eclipses, supernovae, even auroras. But comets and interstellar visitors have a special place because they come from beyond, from outside our solar system, even outside our imagination. They are messengers carrying the weight of distance. In the end, what binds all these reactions together is our need for connection. We don't want to feel alone in the universe. Visitors from the stars, even if they are just ice and dust, give us a sense of relationship. They are proof that the cosmos is not closed. Things travel, systems touch, stories cross the void. That is why Oumuamua sparked so many debates, why Borisov filled us with excitement, why Atlas made us feel fragile. These were not just lumps of matter. They were connections. We know there will be more. The universe is vast, and interstellar objects must pass through the solar system all the time. We've just only begun to detect them. Future telescopes, like the Vera Rubin Observatory in Chile, may discover dozens every year. Each one will bring fresh science, but just as surely, each one will bring new stories, new metaphors, new fears, new poems. Because as long as we are human, we will turn the unknown into meaning. Imagine standing in a quiet room at night, a single window open to the outside. Through it, you glimpse a flash of lightning in the distance, a hint of rain, a sound carried by the wind. The window does not tell you everything about the world beyond, but it gives you just enough to know that a vast landscape exists out there, full of storms and forests and oceans you have not yet seen. That is what interstellar visitors are for humanity. Brief windows to other worlds. They do not stay long, and they do not explain themselves fully. But in their fleeting appearances, they give us precious clues about the galaxies beyond our reach. Every fragment of dust, every unusual orbit, every shimmering tail is a whisper from another neighborhood of the Milky Way. In this section, we explore what these cosmic wanderers reveal about the wider universe. We will slow down, look carefully, and allow each piece of the story to unfold gently, like a stargazer watching the night sky shift hour by hour. If you wanted to study a forest far away, but you could not travel there, you might wait for something carried by the wind, a leaf, a seed, or a feather. Interstellar objects are like those drifting seeds. They are not the whole forest, but they are physical samples of environments we cannot reach. Oumuamua may have been a shard from a planet-forming disk around a distant star. If so, it tells us that other planetary systems also shatter and fling debris into space. Borisov was icy and comet-like, showing that cold, outer regions of alien systems produce the same snowy wanderers we do. 3I Atlas, though fragile, hinted at extreme delicacy, perhaps revealing what happens to comets when they drift for eons through radiation-filled space. Together, these three visitors are like three different feathers blown in from unknown forests. They are proof that the Milky Way is not empty. It is alive with drifting fragments, castaways from countless star systems. Before 2017, no one had seen an interstellar object up close. Then, suddenly, 3 appeared in just a few years. What does that mean? Astronomers realize something astonishing. Interstellar visitors are likely common, not rare. We just had not noticed them before, because they are small, fast, and faint. Now that our telescopes are sharper, we catch them. If Oumuamua and Borisov were found within 2 years of each other, then perhaps there are millions of such objects passing through the solar system every year, most unseen, drifting silently in the dark. The ones we detect are simply the brightest tip of an invisible iceberg. That realization changes our perspective. The solar system is not an isolated bubble. It is constantly being brushed by the cosmic tide as fragments from other stars slip in and out like fish gliding through a net. These interstellar fragments are not just wanderers. They are participants in a galactic dance of recycling. When a star system forms, much material is left unused. Gravitational nudges fling comets and rocks outward, some of which escape completely. Once free, they drift across the galaxy, perhaps for billions of years. Eventually, a few stumble into another system, ours, for example. This means the Milky Way is engaged in a kind of cosmic sharing program. Every star contributes debris to the galactic sea, and every star receives it in return. In theory, this exchange could spread organic molecules, the building blocks of life, from one world to another. Some scientists call this idea panspermia. Whether life itself can hitch such a ride is unknown, but the thought is humbling. The seeds of life may not belong to any one system, but to the galaxy as a whole. Each interstellar visitor holds unique fingerprints of its birthplace. A comet like Borisov suggests a cold outer disk, rich in ice, much like the Kuiper Belt beyond Neptune. An elongated shard like Oumuamua suggests violent processes, collisions, planetary migrations, or even tidal tearing near a star. A fragile, easily shattered body like 3I Atlas may point to environments where radiation gradually weakens icy bodies until they can barely hold together. By studying these traits, astronomers build a map of diversity across the galaxy. We may never see these alien star systems directly, but their discarded fragments carry their stories. It's as though we are reading scraps of letters blown across an ocean. Each one is incomplete, but together they suggest that other worlds follow familiar rules, yet also contain surprises we could never invent ourselves. Perhaps the most profound window these visitors open is the one into life's possibilities. Comets are known in our solar system to carry water, carbon, and organic molecules, the essential ingredients for biology. If interstellar comets also carry these, it suggests that the galaxy is seeded with life's ingredients everywhere. When scientists analyzed Borisov's light, they detected cyanide gas, a molecule also found in our comets. They found dust grains similar to those in our solar system. This suggests that chemistry across the galaxy is not exotic or unique, but familiar. The same molecules form again and again, under different stars, in different places. This universality is a comforting thought. It means Earth is not special in its ingredients. We are part of a larger recipe the cosmos seems to repeat. If life emerged here, then perhaps it emerges elsewhere too, not as a miracle, but as a natural consequence of common chemistry. Some interstellar objects may be unimaginably old. If a comet was ejected from its home system billions of years ago, it could have drifted through space since before Earth formed. That makes these visitors time capsules. When one passes by, we are not just looking at a piece of another star system. We may be seeing a fossil from the galaxy's youth. Studying its composition could tell us what the Milky Way was like when it was younger, when stars were forming rapidly and planets were new. This is why astronomers are so eager to catch and study these wanderers in detail. Each one is not just a visitor. It is a messenger from another time. The ultimate dream is to catch one. Right now, we only observe them from afar with telescopes. But plans exist to launch spacecraft that could intercept a future interstellar visitor. One proposed mission is called Comet Interceptor, a European Space Agency project to wait in space until a suitable target is spotted. When a new object appears, the craft could be redirected to fly by and study it up close. If the target turned out to be interstellar, it would be humanity's first chance to examine alien material directly. Imagine the thrill. Images of the surface of an object that came from another star, measurements of its dust, its ice, its gases, perhaps even samples returned to Earth. That would transform interstellar visitors from distant curiosities into tangible pieces of the galaxy held in our hands. Interstellar objects do not just reveal science, they open a philosophical window too. They remind us that we are not alone in our cosmic processes. Other stars form comets, other systems fling rocks outward, and other fragments wander endlessly. When we see one streak across our sky, we are reminded that the galaxy is a connected whole. Stars are not isolated. They exchange debris like neighbors trading seeds. In that sense, the Milky Way is one vast ecosystem, with matter cycling between its members endlessly. For humans, who often feel small and separated, this truth can be comforting. We are part of a galactic web of exchange. Even the rocks in our sky carry stories from places we cannot yet travel. Of course, the window is narrow. We see only flashes. We cannot control when the next visitor will appear or what shape it will take. Most slip past unnoticed, like whispers in a crowded room. This limitation teaches patience. Science often advances not by abundance, but by waiting for rare chances. When the next interstellar visitor comes, it will be a test of how ready we are, how well we have learned from Oumuamua, Borisov, and Atlas, and how quickly we can act to study the next. Finally, these visitors reveal something not about the galaxy, but about us. They show us our hunger for connection, our longing to understand what lies beyond our world. We watch them not only for data, but for meaning, the excitement around each discovery, the debates, the dreams of missions. They are all signs of humanity's restless curiosity. Interstellar objects are mirrors, showing us how deeply we yearn to be part of a larger cosmic story. Close your eyes for a moment and imagine yourself standing on a quiet hillside at night. The air is cool, the crickets are humming, and above you stretches the vast velvet black sky. Millions of stars shine, some faint, some bold. Among them, scattered like whispers, are planets, moons, dust clouds, and maybe, just maybe, an interstellar traveler gliding silently into our neighborhood. Right now, telescopes all over the world are watching. Scientists are waiting for the next visitor, the next surprise messenger from beyond our solar system. Oumuamua came first, strange and mysterious. Then came 3I Atlas, beautiful but fragile, breaking apart before it could finish its story. And in the future, there will be more. Countless more. This is the section where we stop looking backward and instead turn our gaze forward toward the future of interstellar visitors. What will we find? How will we prepare? And what do these messengers mean for humanity's story among the stars? One thing astronomers know for sure: 3I Atlas was not the last. The Milky Way galaxy is filled with billions of stars, and around those stars, countless comets, asteroids, and planetesimals are tugged and tossed by gravity. Sometimes, a star's pull ejects these small bodies entirely, flinging them out into the vast interstellar void. They drift, homeless, until they pass close to another star system. Our solar system is not a fortress. It is more like a crossroads, wide open to travelers from the galactic highway. Sooner or later, more interstellar objects will wander through. Some will be icy like comets. Others may be rocky like asteroids. A few might even carry surprises, chemicals we've never seen before, or structures that challenge our imagination. Astronomers estimate that thousands of interstellar visitors pass through our solar system every year. Most are too faint to see, slipping by undetected. But as our telescopes grow sharper, our chances of catching them improve. The future of interstellar discovery rests on new tools, bigger, smarter, faster telescopes. Opening soon in Chile, the Rubin Observatory is like a giant time-lapse camera for the universe. Its massive 8.4-meter mirror will scan the entire visible sky every few nights, capturing breathtaking detail. Unlike older telescopes that focus on one patch at a time, Rubin will cover everything, again and again. This constant watchfulness makes it perfect for spotting fast-moving visitors. Oumuamua was only noticed after it was already leaving. Rubin could catch the next one on the way in. That means more time to study, more chances to launch probes, more opportunities to unlock interstellar secrets. Telescopes on Earth are powerful, but they have to peer through Earth's atmosphere, which distorts and blocks some light. Space telescopes, like Hubble, James Webb, or future missions, float above the air, seeing with perfect clarity. Webb, in particular, could study the chemical signatures of gases released by an interstellar comet. Imagine knowing not just what a visitor looks like, but what it smells like, whether it carries water vapor, carbon monoxide, or exotic ices from alien stars. It's not just about bigger glass lenses. Computers are joining the hunt too. Artificial intelligence programs can sift through oceans of telescope data, flagging tiny moving dots that might be interstellar objects. They can catch things human eyes might overlook. In a sense, we are training digital night watchmen to look up at the cosmic sky with us, tirelessly, without blinking. Every visitor teaches us lessons that prepare us for the next. From Oumuamua, we learned that interstellar objects may not behave like the comets and asteroids we know. They might be oddly shaped, tumbling, or driven by forces we don't yet understand. From 3i Atlas, we learned that fragility is part of the story. Not every traveler will survive its close brush with the sun. Some may crumble into dust, offering only fleeting glimpses of their inner makeup. These lessons mean that next time, scientists will act faster. They'll know to capture as much data as possible in the first weeks, before a visitor spins out of reach or dissolves into fragments. Catching a visitor with telescopes is one thing. But what if we could actually go to it? Imagine a small spacecraft waiting in orbit around Earth or Mars. The moment an interstellar object is spotted, the spacecraft launches, racing to intercept. It approaches slowly, cameras and instruments ready. For the first time in history, humanity could touch, literally touch, something from another star system. This dream is not science fiction. In fact, space agencies and private groups are already discussing interstellar probe missions. Breakthrough Starshot, a private initiative, imagines using powerful lasers to push tiny spacecraft to incredible speeds, fast enough to reach other stars. While that's still far off, the same technology could, in theory, help us chase interstellar objects. ESA, European Space Agency, has designed a mission called Comet Interceptor, which will sit ready in space, waiting for a new comet or interstellar visitor to appear. Once spotted, it will swoop in for a flyby. The challenge is speed. Interstellar visitors move fast, far faster than anything in our solar system. By the time we spot them, they're already racing through. Intercepting them is like trying to throw a paper airplane at a bullet mid-flight. Yet, as technology improves, what feels impossible today may be routine tomorrow. You might ask, why do we care so much about these icy wanderers? Aren't they just rocks and dust? The answer is bigger than science alone. Every interstellar visitor is like a bottled message, carrying chemistry and structure from a star we may never see up close. By studying them, we get a sample of other planetary systems without leaving home. 1. Hints of life's building blocks. Comets in our own system contain organic molecules, some of the basic ingredients of life. If interstellar comets carry the same, it suggests the seeds of life may be common across the galaxy. Perhaps worlds everywhere have been sprinkled by the same cosmic recipe. 2. Testing our technology. Chasing interstellar objects pushes us to build faster spacecraft, sharper telescopes, and better AI. These technologies don't just serve astronomy, they ripple into medicine, computing, communication, and more. 3. Inspiration for humanity. Beyond the practical, there is the poetry. To know that something from another star system passed by, briefly within reach of human eyes, is humbling. It reminds us we are not isolated. We are part of a galactic community, even if the other members are silent. Most interstellar objects will be ordinary, ice, dust, stone. But astronomers keep a small corner of their minds open to the extraordinary. What if one day a visitor is not natural at all? What if it is artificial? Something built, not born? This idea is not science fiction fantasy. It has been seriously debated. Some scientists wondered if Oumuamua's odd behavior might be due to artificial origins, a thin solar sail, perhaps, drifting across the galaxy. While most evidence points to natural explanations, the possibility lingers, delicate and thrilling. If an artificial object ever did pass by, it would change everything. It would mean we are not alone. It would mean that other civilizations have crossed the stars before us, leaving behind fragments, gifts, or even breadcrumbs for others to find. The chances are slim, but the door remains open. And that alone is enough to fuel dreams for generations. Waiting for interstellar visitors requires patience. They do not come on a schedule. They arrive unannounced, stay briefly, and vanish into the dark again. But patience is something humanity has always had. We waited thousands of years to understand the motions of planets. We waited centuries to send machines into orbit. We waited decades to walk on the moon. And now, we wait for the next messenger, knowing it will come, knowing it will surprise us. Some children alive today may grow up in a time when intercepting interstellar visitors is routine. They may look back at Oumuamua and 3I Atlas the way we look at the Wright brothers' first flight, clumsy but historic, the start of something vast. Picture it. The year is 2100. Humanity has colonies on Mars and space stations around distant moons. Telescopes map not just the solar system, but nearby stars in detail. And every decade or so, a new interstellar visitor swings through. Small spacecraft launch like dragonflies, buzzing out to meet them. Children in schools watch live feeds as probes skim past alien comets, showing their icy cliffs and jets in real time. Scientists analyze the dust, comparing molecules from one system to another. Slowly, the galaxy stops being an abstract blur and becomes a place we are learning, piece by piece, to touch. That is the future interstellar visitors promise. Not just knowledge, but connection. When you hear the words, an object from another star system, your mind doesn't immediately leap to chemistry charts, orbital mechanics, or faint telescope data points. No. Your imagination does something very different. It begins to wonder. You picture a mysterious shard of alien ice, or perhaps a cosmic ship sent across the void. You imagine what it means that something, anything, has wandered into our neighborhood from the deep interstellar dark. This is the magic of interstellar visitors like Oumuamua and 3I Atlas. They are not just astronomical curiosities, they are also cultural sparks. They light fires in human imagination, pushing us to dream, to speculate, and to weave new stories about our place in the universe. In this section, let us slow down and explore how these visitors ripple outward beyond astronomy, shaping literature, art, science fiction, philosophy, and even how ordinary people look up at the night sky. Long before telescopes, before mathematics could describe the pull of gravity, humans looked up and told stories about objects in the sky. To the ancient Greeks, a comet was the hair of a wandering star. The very word comet comes from comets, meaning long-haired. In China, comets were thought to be celestial broomsticks, sweeping bad luck or omens across the heavens. Among the Yoruba in West Africa, shooting stars and fiery streaks were interpreted as messages from the spirit world, sometimes warnings, sometimes blessings. Medieval Europeans often panicked at the sight of comets, believing they foretold plagues, wars, or the death of kings. Every culture wrapped cosmic visitors into myth. They were too strange, too unpredictable, too fleeting to be ignored. And now, in the 21st century, that same instinct is still alive. When Oumuamua streaked past us in 2017, and when 3I Atlas broke apart in 2020, the world did what humans have always done. We began telling stories. Let's pause on Oumuamua because it was the first of its kind. Officially, it was a rocky, elongated object tumbling as it sped away from the sun. But unofficially, it became one of the most debated what-ifs of modern times. Some scientists, like Harvard astronomer Avi Loeb, suggested it might be an alien probe, a kind of interstellar sail drifting on radiation pressure. This idea was controversial, yes, but it caught the public's imagination. Suddenly, Oumuamua wasn't just a rock, it was a mystery novel written in the sky. Think about how quickly the cultural machine worked. Books were written, both scientific and speculative. Loeb's own Extraterrestrial became a bestseller. Movies and TV latched onto the idea. Science fiction scripts began referencing strange interstellar objects. Memes filled social media. When your space rock looks like a spaceship. Even artists painted interpretations of a sleek alien craft gliding silently between stars. In just a few months, Oumuamua had gone from a faint dot in a telescope to a cultural character. Mysterious, provocative, and unforgettable. Then came 3I Atlas. Unlike Oumuamua, it did not survive long enough to be fully studied. But that fragility gave it a different kind of cultural resonance. Instead of being a possible alien probe, it became a symbol of impermanence. Writers compared it to a mayfly, living briefly before disintegrating. Others likened it to a traveler collapsing from exhaustion after a million-year journey. Poets saw in it a metaphor for the human condition, fragile, fleeting, yet beautiful in its short existence. Even though its scientific story was cut short, 3I Atlas entered cultural memory as a comet that broke our hearts a little, a reminder that not all visitors from the stars can survive the embrace of our sun. The announcement of an interstellar object always ripples outward beyond astronomy circles. News outlets cover it. People ask questions. Social media threads blossom. And in those moments, science becomes part of everyday conversation. Some common reactions include awe and wonder. People marvel that an object from another star system has come close to Earth. It makes the universe feel less distant, more connected. 2. Fear and worry. What if it hits us is often the first question from non-scientists. Luckily, both Oumuamua and 3I Atlas were never on a collision course. But fear itself is revealing. It shows how cosmic visitors awaken primal instincts. 3. Humor and creativity. Jokes spread fast. Artists sketch aliens waving from the rock. Cartoonists imagine comets filing travel visas at Earth's border. Humor is one way humans process the enormity of cosmic events. Philosophical reflection. Some pause to ask deeper questions. If things from other stars drift into our system, does that mean life, or its ingredients, could drift too? Are we alone, or are we part of a much larger cosmic ecosystem? Science fiction has always thrived on the outsider from space theme, but real-life interstellar objects give writers a fresh spark. In novels, authors imagine alien vessels disguised as comets. In poetry, fragile visitors become metaphors for love, death, and destiny. In children's stories, they become friendly travelers, stopping by Earth for a cosmic snack before moving on. Even if most people will never read the technical papers about 3I Atlas, they may one day encounter it as a character in a story, and that story will carry some truth about its real journey. Why do we turn rocks and comets into symbols? Because humans are meaning makers. We cannot resist. A comet breaking apart becomes a symbol of fragility. A mysterious elongated object becomes a symbol of the unknown. An interstellar visitor becomes a symbol of connection. A reminder that our solar system is not isolated, but part of a larger galactic neighborhood. In philosophy, such metaphors are bridges. They connect the cold facts of astronomy to the warm questions of human life. Visit online galleries, and you'll find paintings of Oumuamua rendered as sleek alien craft. You'll see digital art of comets glowing against star fields. Sculptors have even carved elongated stone shapes as tributes. Music, too, has taken inspiration. Experimental composers have written tracks mimicking the tumbling spin of Oumuamua. Others have set orchestral pieces to images of comets, blending science with sound. Art transforms data points into emotional experience. And in doing so, it brings interstellar visitors down to Earth, into our galleries, our headphones, our imaginations. At the end of the day, the cultural impact of interstellar objects is less about the objects themselves and more about us. Oumuamua did not care that people argued about its origin. 3i Atlas did not crumble poetically for our benefit. These are natural things, indifferent to human meaning. But we, fragile, meaning-seeking creatures, can't help but project ourselves onto them. We see their journeys as reflections of our own. We see their impermanence as echoes of mortality. We see their mystery as a challenge to explore. In this way, interstellar visitors become mirrors. They reflect not just starlight, but our own hopes and fears. Even outside art and literature, the influence spreads. Education. Teachers use the stories of Oumuamua and 3i Atlas to inspire students, showing that discovery is still happening right now. Philosophy of science. Debates about alien probes versus natural rocks remind us how science works, balancing evidence with imagination. Public engagement. NASA press releases about these visitors receive millions of views, far more than many other technical discoveries. The ripple effect is powerful. A faint dot in a telescope can shape how millions of people think about the cosmos. Picture this. You are sitting in your room late at night. The lights are dim, the world is quiet, and the air feels still, as if holding its breath. Above you, the stars stretch endlessly, each one a sun, each one perhaps surrounded by planets. Somewhere out there, across those gulfs of darkness, a traveler begins a journey. It may be a comet, it may be a rock, it may be dust or ice. But whatever it is, it carries with it the raw ingredients of a story. And maybe, just maybe, the ingredients of life itself. That is the hope, the dream, and the puzzle wrapped into every interstellar visitor we've ever seen. Not just because they are rare, not just because they are beautiful, but because they may hold clues to life's grandest question. Are we alone? Our solar system is full of comets and asteroids. We have studied many of them, even landed spacecraft on their surfaces. They tell us about our own origins, what early Earth was made of, what icy molecules fell onto our young oceans, and how life might have begun here. But when something like Oumuamua or 3i Atlas passes through, it changes the game. These visitors are not from our backyard. They are from someone else's backyard. Other stars, other systems, other nurseries of planets. That means they may carry chemical fingerprints that do not match ours. They may carry exotic molecules. And in some wild but not impossible scenarios, they could carry seeds of life. This idea is called panspermia, the possibility that life, or at least the raw materials of life, can spread between star systems. To understand why scientists dream about life hitchhiking on comets, we have to look at what these cosmic snowballs contain. Even in our own solar system, comets are full of water ice, the same H2O we drink, frozen for billions of years. Carbon compounds, the backbone of organic chemistry. Amino acids, tiny molecules that are the building blocks of proteins. Simple sugars and alcohols. Yes, comets carry a cocktail of chemistry, though not one you'd want to sip. When the spacecraft Rosetta visited Comet 67P Churyumov-Gerasimenko, it found not just water, but organics, glycine, phosphorus, and other life-related ingredients. This was a stunning confirmation that the ingredients for biology are scattered across space. Now imagine comets that formed around another star. They might carry the same chemicals, or different ones we haven't even imagined. Every interstellar visitor is a mystery box of chemistry drifting through the cosmos. Here's the next big question. Even if comets carry life, could that life actually survive? Space, after all, is not friendly. It is cold, airless, and filled with radiation. A microbe drifting naked through interstellar space would likely be fried in no time. But a microbe buried deep inside a comet's ice? That's another story. The ice could act as a protective shield, blocking dangerous radiation. Dormant microbes could hibernate, waiting for millions of years. On arrival at a new star system, the comet might warm up, releasing those microbes into new environments. Some experiments on Earth suggest this isn't impossible. Scientists have frozen bacteria, exposed them to vacuum, even blasted them with ultraviolet light. And some survived. This resilience fuels the idea that panspermia could be more than just science fiction. When Oumuamua passed through in 2017, most astronomers believed it was a fragment of rock or ice. But its strange acceleration, the way it sped up without any visible tail, left room for speculation. Avi Loeb, an astronomer from Harvard, famously suggested it might be a piece of alien technology, perhaps a light sail drifting between stars, perhaps a probe sent long ago. Most scientists were skeptical, but the debate caught fire. Why? Because Oumuamua reminded us how little we know about interstellar material. If one strange rock could spark such questions, then future visitors might carry even bigger surprises, including signs of life or technology. When 3I Atlas crumbled in 2020, it disappointed many astronomers. They had hoped to study it up close, to measure its chemistry, to look for exotic molecules. Its breakup made that harder. But even in its disintegration, it sparked the imagination. If it carried organics, those molecules scattered into the solar system's space environment. For a brief time, Earth shared dust with a visitor from another star. And while the fragments were too faint to capture in detail, the possibility lingers. What secrets were lost in that cloud of dust? If comets can carry life, then interstellar visitors like Oumuamua and 3I Atlas could be messengers of biology. Perhaps life does not start fresh on every planet. Perhaps it spreads, slowly but steadily, across galaxies. This doesn't mean aliens are hitchhiking on comets like interstellar buses. More likely, it means the chemistry of life, the amino acids, sugars, and simple molecules, may be seeded everywhere. Every star system may inherit a starter kit. And that leads to a profound thought. Maybe life is not rare at all. Maybe it is common, written into the fabric of galactic chemistry. Why does this matter so much to us? Because humans have always wondered if we are alone. For thousands of years, we have looked at the stars and imagined neighbors, gods, spirits, other worlds. Now, with telescopes and spacecraft, we are finally close to answering scientifically. Every interstellar visitor is like a postcard from another neighborhood. It doesn't spell out a full story, but it hints at possibilities. It whispers, "You are not the only ones. The universe is bigger, richer, and more connected than you think." Future technology may finally let us catch one of these visitors in the act. NASA has proposed missions like the Comet Interceptor, designed to sit in wait until a new comet, maybe even an interstellar one, passes by. Then it could swoop in, fly alongside, and sample its chemistry directly. Imagine the drama of that moment, a spacecraft racing to meet a traveler from another star, scooping up dust, peering into its icy heart, and sending the results home. If we find amino acids from another star system, the implications would be staggering. Life's chemistry would be confirmed as universal. And if, against all odds, we found microbes, that would change everything. It would prove that life does not belong to Earth alone. It would prove that biology is a galactic phenomenon. Whether or not comets carry life, they carry perspective. They remind us that the universe is not static. Materials move. Systems exchange fragments. We are not isolated. We are part of a grand circulation of dust and ice. It's almost like a cosmic handshake. A comet from another star brushes through our skies, saying, "Hello, neighbor. Here's a little bit of what made me." As we close this section, imagine again that late night sky. The stars are out. Somewhere, another interstellar traveler may already be on its way, invisible to us for now, but drifting steadily toward our system. Maybe it carries only dust. Maybe it carries the ingredients of life. Maybe it carries a story older than Earth itself. When it arrives, we will be watching. We will be ready. And in its fragile form, we may glimpse not only another world, but also the possibility that life, the same spark that flickers in you right now, exists across the galaxy.